Before we continue, yeah, so I think I need to make some changes. Yeah, so the changes is, I think when I was explaining about here, okay, when the electrons, okay, when the electrons moving from this part, okay, to here, okay, to BR, okay, I think previously I would have explained that one electron went out. Okay, actually it's not true. Yeah, it's actually two electrons goes out. Yeah, because in order to form one bond, okay, you need to have a pair of electron. Yeah, you need to have a pair of electron, then only the BR can be bonded. So instead of what happens over there, not only one electron goes out, okay, it's actually two electrons go out. So you are going to actually have, okay, two electrons over there. Yeah, two electrons. So when I draw over here, still correct, okay, but it's only four electrons. Okay, there are four electrons in the benzene ring. Okay, instead of 5 electrons, or instead of 6 electrons, which is supposed to be 6. Yeah, so then only, okay, do remember here, okay, when they form the bond, okay, the remaining 2 electrons that's over here, they start to come in and replace. Okay, then only they are going to have over here. So the adjustment over here is, okay, how many electron that goes out. Okay, the number of electron that went out is actually 2. Yeah, not only one. Yeah, 2 electrons. So it means that if they ask you, yeah, in this, let's say for example, if you have like this and then plus, okay, what does it mean? Okay, it just simply means that they are going to be 4 electrons being shared with how many carbon atoms? How many? 1, 2, 3, 4, 5. 5 carbon atoms. Okay, so do remember 4 electrons being shared with 5 carbon atoms. Okay, so that is my mistake. Yeah, when I was explaining to you in the morning, or maybe yesterday. Okay, the mistake is, okay, I would have actually said only 1. Yeah, I got confused with 5 carbon. Okay, but in order to form a bond, okay, you need one pair of electron, or 2 electrons. Yeah, you need 2 electrons, so there will be 4. Okay, anyway, I'll continue. Yeah, I'll continue. You see, this is going to be the electrophilic substitution, okay, of the benzene. Okay, and then today, okay, we also learned about, okay, we have learned about, okay, let me check. Yeah, whether everyone is here. Okay, we also have learned about methylbenzene. Yeah, so I'll just go through all this again. Yeah, so quickly. So you have the methylbenzene. Okay, methylbenzene, when you react with Cl2, yeah, what will happen? Okay, so the reaction is going to be, you are going to still require to use the catalyst AlCl3 or FeCl3, okay, but you are going to have a mixture of product, which is going to be the CH3 methyl is going to be 2,4,6 directing. Yeah, so it's going to be, you are going to have Cl over here, and then you will have a benzene, okay, methylbenzene, which another Cl over here, okay, and the 6 no need because it's the same over here, so plus 2 ACl. Yeah, so this one is going to be okay, this one you complete. Okay, you put 2. Okay, how many Cl? Okay, so Cl is going to be 2 molecules of Cl. Okay, so this one, if you write it in full, yeah, and do remember, if you use excess Cl2, yeah, if you use excess Cl2, okay, then the reaction you are going to have slightly different. Okay, where you are going to have Cl2, you are going to have still the same AlCl3, but you are going to have more substitutions. Yeah, so CH3, Cl over here, and Cl over here, plus CH3, okay, Cl over here, and Cl over here. Okay, and one more is going to be all. Yeah, CH3, Cl over here, 2, 4, 6. Okay, and then HCl. Okay, how many HCl, then you just follow 1, 2, 3, 4, 5, 6, 7. So 7 over here. Okay, and then this one is going to be 7 also. This is going to be 3. Okay, so this is how you do. Yeah, we have already done this, okay, earlier, and I would have actually also went through just now about free radical substitution. Yeah, free radical substitution. So I'll just put FRS, yeah, free radical substitution. Okay, free radical substitution. Okay, they happen only for alkylbenzene. Yeah, so arene, alkyl arene. So basically they don't happen for benzene. Yeah, so let's say, for example, if I have a methylbenzene, okay, and what you need to do, okay, for methylbenzene, it must be boiling. Okay, you boil, and then, okay, let's say Cl2, and it must be with the presence of UV light. Okay, so what will happen, you are going to have, okay, the benzene, so CH2Cl. Okay, so do remember there is no direct substitution over there into the benzene ring, okay, for free radical substitution. Okay, so plus HCl. If it is going to be excess, okay, then you are going to get all the hydrogen, okay, will be replaced by the Cl. So if that is going to be excess, you're going to have this. Yeah, so this is what we have done for the, I think, for just now in the morning. Yeah, for the morning. So you can see roughly, you see electrophilic substitution for benzene. Yeah, I'll just write down over here. Maybe write down bigger a bit. Okay, this one is for benzene. Okay, benzene. And then for this one, it's going to be methylbenzene. I think for FRS and the electrophilic substitution over here, basically they are focusing on methylbenzene. Okay, hold on. Okay, so now, okay, I am going to introduce to you another type of reaction. Yeah, another type of reaction. So we'll go back to the PowerPoint first. Okay, so you see here. Okay, this one, okay, we have already done this. So we'll just go to the nitration. Yeah, so coming back to benzene again. Yeah, coming back to benzene again. So this is going to be a reaction what we call as nitration. Yeah, nitration is going to be NO2. Yeah, NO2 will be, if you say nitrobenzene, yeah, nitrobenzene is going to be a benzene, okay, and then they put the NO2 over there. So this is nitrobenzene. Yeah, so the electrophile for this is going to be the NO2 plus ion. Yeah, the actual name is going to be nitronium ion or nitrile cation. Is it important to memorize the name? Actually, not necessary. Yeah, so NO2 plus is okay already. Yeah, so as long you know the NO2 plus is going to be the electrophile, is okay. Now, the how do you make the electrophile is the same. It's almost the same concept. Yeah, it's almost the same concept with how you make the electrophile for this one. Okay, you can see how you made the electrophile for the from the FeBr3. Yeah, but what we are going to do over here is going to be, I'll just show you here. We are going to use concentrated, okay, concentrated H2SO4 and concentrated nitric acid, and the temperature in your textbook is 55 degrees Celsius. Yeah, but in your syllabus, okay, in your syllabus they mention is 25 degrees Celsius to 60 degrees Celsius. So up to you which one you want to use, okay, but I will stick to, I think most of the students, they prefer to use the 55, but I'll leave it to you. Yeah, 25 degrees Celsius to 60 degrees Celsius. Okay, they are going to have a reaction. Yeah, so I will write down the reaction for you. HNO3, okay, HNO3 plus H2SO4. Okay, if you memorize, it's easier a bit. You just put 2 over there. Yeah, this will help you to get the equation faster. Yeah, and this is going to give you, okay, they are going to give you the electrophile that you want, which is going to be NO2 plus. Yeah, so if you have NO2 plus, okay, it means that if you follow here, what is remaining? H is gone. Yeah, and then there is O is gone. Yeah, it's not being used. Yeah, it's not being used. Okay, the NO2 is taken. Yeah, and then if you this is going to give you, okay, I think most of you know, if you have H2SO4, when I remove one H, okay, I am going to have HSO4 minus plus H plus. Yeah, if you put, okay, let's say for example HSO4 minus, okay, I want to remove another one more electron. Yeah, I will get SO4 2 minus plus H plus. I think most of you should know this. Yeah, the charges. Okay, so in this case, you are going to remove one of the H, so you are going to get HSO4 minus. Okay, I will erase this part. Since we have 2 moles, yeah, so it must be 2 over here. Yeah, so what is remaining or left over? Yeah, left over, basically you are removing the 2H, yeah, 2 hydrogen. So I'll just put H plus and then H plus. Okay, so 1 H from 1 mole. Yeah, 1 H plus from 1 mole. So what is remaining over there? Okay, if you want to see, yeah, remaining, whatever that is left over here should be combined. Yeah, so 3H and 1O, okay, that will give you H3O plus. Okay, so that is hydroxonium ion. Yeah, so why we did this? Okay, basically I just want to know, yeah, how do I get the electrophile? Yeah, and the rest is all very easy. Yeah, the rest all we have already learned. Okay, where you have the benzene. Yeah, when you have the benzene and then you have the electrophile. Okay, so we know that, okay, the electrophile is will attack, okay, the benzene ring. Yeah, but be careful when you show the curly arrow. Yeah, the arrow must be from the benzene ring to NO2. And what will happen, okay, during this process, okay, as I mentioned to you, they are going to form, earlier they already have the hydrogen. Yeah, they already have the hydrogen. They are forming a new bond with NO2. Yeah, so it means that they need to take 2 electrons from the 6 electrons in the ring, and they form a new bond, okay, with the NO2. So I am going to have, okay, like this. H will be there. Okay, so now a new bond is being formed from the 2 electrons. Okay, so you will have NO2 over there. So there are total of 4 electrons only being shared to 5 carbon atom. Yeah, so this is the difference over here. Remember last time I told you, okay, 1 electron goes. No, it doesn't make sense. Yeah, 2 electrons will go. Okay, but these 4 electrons remaining will be shared towards the 5 carbon atoms, and they are like lost the 2 electrons over there, so they are positively charged. Yeah, they want the electrons back. Okay, so how do they get the electron back? Yeah, so basically the 2 electrons from the hydrogen, the bond between carbon and hydrogen, okay, will be taken in. Okay, they want them to come in, so that will make the heterolytic fission will happen. So you are going to have a normal nitrobenzene. Okay, you will have nitrobenzene, and then, okay, there is going to be H plus. Yeah, so what will happen to this H plus? Okay, I will let you guys to decide what will happen, but you can just leave it as H plus. But if you want to use the same method like last time, yeah, it will react with the catalyst again. So you can also write down, okay, the H plus can join with HSO4 minus to give you H2SO4 is also correct. Yeah, so that is going to be, so basically they will react with this. Okay, they will react with that. Okay, so this one is going to be the mechanism of the reaction. Okay, the only thing is 55 degrees Celsius, and it must be reflux. Okay, it must be reflux, and this reaction, okay, is known as nitration, and it happens for, okay, it happens for benzene. Okay, it happens for benzene. Okay, I'll go back here. Okay, let's actually check over here. So you see here, okay, whatever things that I have mentioned just now, okay, it's all here. Okay, it is reflux with benzene at 55 degrees Celsius. And then you can see all the mechanism, okay, like what we have discussed. Yeah, the only thing that you will notice over here is going to be, you will notice that you will have H2O over there. Yeah, so basically this is H2O. If you write down, okay, the reaction directly, okay, if you write down the reaction directly is, okay, if you put like this, okay, you know, HNO3, so NO2, okay, will go there, and then there is H, okay, this H is going to be replaced by the NO2. So what is left over here? H and O. So H comes out, okay, of course, you will know easier way to represent is H2O. Yeah, so that's why they actually put it as H2O over there. Yeah, so that one, okay, if you ask me the reason, yes, I already explained over here the reason. And actually, if you just put as H plus like that, it's already correct. Yeah, it's already correct. Now, the mechanism of the reaction, yeah, is going to be whatever things that I explained, okay, is being explained again. Okay, so the mechanism of the reaction is basically they have two stages. Okay, actually, no need to mention two stages. Yeah, so basically, they say the first one, okay, you are going to have the electrophile attract to high density of the pi bonding. Then they say it's pair of electrons. So two electron, yeah, two electron donated to form covalent bond, yeah. And then the delocalized electron ring, delocalized ring is disrupted. So it means over here now, instead of 6 electrons, you are going to have only 4 pi bonding electron, 4. Okay, and positive charge spread over 5 carbon atoms. Yeah, not so this is going to be the 5. Okay, 1, 2, 3, 4, 5. Okay, that's why you have this something like this. Yeah, and then, okay, the second stage is going to be you are going to restore the delocalized ring. How? Okay, by getting back the pair of electron, okay, from the bonding between carbon and hydrogen. Yeah, so what happens? Okay, they break heterolytically. Yeah, so that will give you the once broken, that will give you the H plus. Yeah, that is why they say heterolytically both electrons go back to the pi system. Okay, and there is going to be what we have just now. I didn't go through further nitration. For further nitration, okay, I will just write down for you. Okay, do remember, okay, this reaction, okay, this reaction can continue. Yeah, they don't actually stop over here, okay, because it's only one replaced. But we know earlier we learned that Methylbenzene, they are going to be electron donating group, so they are going to activate position number 2, 4, and 6. But just in the morning, I mentioned also nitro, yeah, NO2 group. They are electron withdrawing group. Okay, so whenever we are dealing with electron withdrawing group, yeah, electron withdrawing group is going to be going to activate position, okay, number 1. Actually, no need to mention 1. Yeah, so 3 and 5. Okay, they will activate position 3 and 5. So it means that, okay, you are going to have further nitration. Means, okay, you are going to have, let's say, for example, if I have this one and O2 here, okay, I can still get, okay, another, okay, position. This one is going to be counted as 1. Okay, 1. So 2, 3 is going to be NO2. You are going to get this. Okay, and okay, it will be also going to activate position number 5. So NO2 over here also can. Okay, this is what they mean by position 3 and 5 will be activated. So if you come back over here, okay, they say that okay, the further nitration, okay, they can actually produce 1,3-nitrobenzene or 1,3,5 trinitrobenzene. So if it is going to be, let's say for example, okay, they can also give you like this also, NO2 and 1 and 3 only. Okay, so it means you can have further nitration to this and then further to this. Yeah, so that is the meaning of further nitration. Okay, the reaction can continue. Okay, but why position 3 and 5? Okay, this is the reason just now I told you about. We need to talk about the nitro group. Yeah, NO2. Okay, they are generally electron withdrawing group. Yeah, and they will activate position 3 and 5. Okay, so as simple as that. Yeah, so that's going to be the nitration. Yeah, I went through this already just now. Yeah, so the one that I told you to memorize is going to be just focus on the methyl group first. Okay, electron donating. Yeah, if you want to memorize the others, maybe amine and then OH and then Cl. Okay, but this is important. Okay, for here, this one is more important now. Okay, nitro NO2. Yeah, they are going to be electron withdrawing group. Okay, they will activate position number 3 and 5. Yeah, so there are going to be questions over here. Okay, but I think the question we can actually go through later. Yeah, so I will just move on. Okay, to the next part. Okay, so there are going to be other reactions as well. So this one is still benzene again. Yeah, the other reaction is known as alkylation. Okay, or acylation. Okay, alkylation or acylation, and generally they are known as Friedel-Crafts reaction. Yeah, Friedel-Crafts reaction. So the third example, okay, of electrophilic substitution. So if I ask you, can you name the first two example? Yeah, the first two example is the first one is the halogenation. Yeah, halogenation, the reaction to add with the Br2, for example, with FeBr3 as a catalyst. That's the first one. Yeah, and then the second one is the one that you did just now, which is going to be the with the NO2 plus. Yeah, so that is going to be with the 55 degrees Celsius and reflux. Okay, to give you the nitrobenzene. Yeah, that is going to be another type of electrophilic substitution. So this is going to be the third example. Yeah, the third example, so it's known as Friedel-Crafts reaction. So what it is used for? Okay, basically we are going to use this reaction to try to substitute, okay, alkyl group. Okay, we want to substitute alkyl group into benzene. So it means if you are wondering how, okay, how, let's say for example, if I have a benzene and suddenly you have a methylbenzene, how suddenly the methylbenzene, how can you form methylbenzene from benzene? Yeah, how you can form methylbenzene from benzene. So what is happening over here? I am replacing or substituting the hydrogen over here with the CH3. Yeah, so the reaction is going to be known as Friedel-Crafts reaction. So you can actually do this, okay, by, okay, you need to have, okay, let's say whatever alkyl groups that you want, okay, you need to must actually have, okay, the alkyl group, okay, with the halogen. Yeah, so it means the halogenal alkane. Yeah, you need to have the halogenal alkane, and then you use the same method, the AlCl3, the catalyst, okay, because you are trying to put the alkyl group into the carbon or into the ring. Yeah, you're trying to put it into the ring, not into the ring, the carbon. Okay, trying to put something to the carbon in the benzene, yeah, the carbon over here directly. Okay, if you want to put anything to the carbon directly, then you must have a halogen carrier. Yeah, so that's why you must have the catalyst. Okay, so what happens? Okay, they just take this part. Okay, this part, they come over here. Okay, so the H that used to be here, okay, they come out, and then the Cl, okay, they will join with the H over there. They give you HCl. Yeah, quite simple. Yeah, the same thing. Okay, you can also, this is known as alkylation. Yeah, alkylation. You can also do the same thing with acyl group. Okay, acyl group means something that have R, C double bond O, and then the any X is going to be the halogen. Yeah. So if, let's say, for example, if I want to form this kind of compound, okay, this kind of compound, I can actually use this method. Similar way, okay, I will actually try to put this thing in. Yeah, so I used to have the H over there. The H comes out, Cl left over here, so HCl. And then what happens here? I have the CH3, C double bond O, and then the Cl. So I just need to take this part and I put it to the carbon over here. The carbon over here, so we'll have this entire part. Okay, so that is going to be acylation. Yeah, so this is going to be Friedel-Crafts reaction. So they say that it results in introduction of side chain to the benzene ring. Yeah, so they are trying to put the side chain over there. So coming back to, let's say, over here, if I want to actually show you how do I get, okay, for example, I want to show I want to get, okay, from benzene. Okay, from benzene, I want to change this benzene to methylbenzene. Okay, what should I do? Yeah, what should I do? Okay, you just need to put, okay, react with CH3, any halogen, Cl. Yeah, so you just need to have CH3Cl. Yeah, and then make sure you have the catalyst AlCl3. And that's it. Yeah, so this one, the CH3 will go there. Okay, the remaining H over here will give you will combine with the Cl over there, gives you HCl. As simple as that. And this reaction is known as alkylation, or they are known as both alkylation and acylation are known as Friedel-Crafts reaction. Friedel-Crafts reaction. Yeah, so this one, okay, let's say there is another way. Yeah, not CH3, something else. Okay, so if you have, let's say, for example, like this, okay, the H I just put for easier to refer, C double bond O, let's say Cl, and then I have C2H5, for example. Okay, so what happened? Okay, I can actually react the same thing, AlCl3. So the Cl and the H, okay, you will have HCl, and then the product is going to be, you are going to have the carbon bonded with O and then bonded with C2H5. This is Friedel-Crafts reaction. Yes, Clienta, you can go. Okay, so I hope you can understand this. Okay, this one is known as alkylation, and this one is known as acylation, because this is what we call as ethyl chloride. That's why the name is acylation. Yeah, acylation. So that is going to be the Friedel-Crafts reaction. Okay, if you look at the reactions and so on, okay, they actually explain about the mechanism of the reaction. Yeah, if you look at the mechanism of the reaction, okay, first what happens? Okay, they say that, okay, you need to actually make a Cl, okay, the halogen is going to be more electronegative. They will pull the electron. Yeah, so you will have this one as delta positive and then delta negative. Yeah, so the reaction involved, okay, by reacting with electrophile. Yeah, so the electrophile can be formed by adding to the catalyst. So the catalyst there. Yeah, so when you react, okay, when they react with the catalyst, what happens? okay, you are going to get the electrophile and then AlCl4 minus, similar like what you have done earlier. Yeah, you will get the same thing. Then after that, you get the electrophile over there. Okay, this is a lot of electron over there. They move over there. 2 electrons, okay, will be used. Okay, and then now, okay, I want the 2 electrons back. Okay, so what happens to the 2 electrons? They will try to bring it over there, okay, to restore the ring. Okay, in that process, okay, you are going to have the H plus, okay, this one, okay, so the H plus, okay, will come out. Okay, so we know that just now we use the halogen carrier, which is going to be AlCl4 minus. Okay, so you can just put AlCl4 minus. Okay, so what they will give you HCl and then the AlCl3 back. Okay, that's why. Okay, so further alkylation can take place, okay, as the reaction proceeds. Okay, but actually this one is not required. Yeah, so I hope you can understand this. Okay, if you look at it, okay, in the notes just now, they mentioned about, okay, the mechanism for alkylation. Okay, I will show you the mechanism for acylation. Yeah, so that you can also learn. Yeah, so I will repeat it again. Yeah, so what happens first? Okay, this one is the mechanism. Yeah, so the mechanism, what happens first is going to be they are going to be acyl chloride. So C2H5, C double bond O, and then Cl. They are approached by the catalyst AlCl3. Yeah. So what happens generally, this is going to be more electronegative. So this is already delta negative, delta positive. So what happens, okay, the delta negative, they are going to go over here, okay, to the AlCl3. And they are going to form, okay, they are going to form AlCl4 minus, leaving C2H5, C double bond O, and then plus, which is going to be your electrophile, okay, which is your electrophile. And then now let's actually bring in our benzene. So I have a benzene over here. And then I have the electrophile. So let's say I'll draw C plus over here, and then double bond O, C2H5. So what happens over here is going to be the electron will go towards here. Okay, so how many electrons? 2 electrons. Yeah, 2 electrons. So earlier they have the hydrogen. I didn't show that. But what happens? Okay, the 2 you will have something like this. Okay, new bond is being formed. The previous bond will stay. The H, the previous bond. New bond is C double bond O, C2H5. This is the new bond. And we want, okay, the 2 electrons back. So they try to get it from the hydrogen. Okay, they try to come in. And you are going to have, okay, the reaction. You are going to have the ring back, C double bond O, C2H5. That leaves the H plus, okay, alone. So this H plus, they will react with the halogen carrier earlier. So they are going to give you AlCl3 plus HCl. Yeah, so that one is going to be also here. Can you understand this, Michelle? Okay. Yeah, so similar. Yeah, so let it be alkylation or acylation. The reaction, the way we draw is going to be quite similar. Yeah, the next thing that I want to teach is going to be the oxidation. Yeah, so this is supposed to be I wanted to finish this so that you can start discussing questions. Yeah. Anyway, you see the oxidation is quite easy also. Yeah. The oxidation is going to be, this will happen. Yeah. For methylbenzene. Yeah. This is for any alkyl compound. Yeah. Methylbenzene and so on. So this is going to be if you have the methylbenzene, or any you know, ethyl benzene or something like that, okay, you are going to be oxidized, okay, it's going to be oxidized, okay, to give you a benzoic acid, okay, it will give you a benzoic acid. So no need to memorize anything over here, yeah, no need to memorize anything over here. So it's just going to when you oxidize, okay, automatically this one carbon over there, they are going to change, okay, into C double bond O, OH, okay. So since you are there is going to be they are going to be yeah, so C double bond O, OH, okay, if you want to memorize this also can, yeah. So basically you are going to have 3 hydrogen, so 3 hydrogen over there, 3 oxygen over there. So if you want to memorize, up to you, yeah, up to you, but you just need to know, okay, that, okay, if you have, okay, if you have another type of, let's say for example C2H5, yeah, if you have C2H5, now if I oxidize, it is very important to know this, okay, even though there is 2 carbon, yeah, automatically when you oxidize, they are not going to give you the 2 carbon carboxylic acid. They will still maintain 1 carbon which is going to be benzoic acid. It means the product is the same, okay, but the side product, okay, they will give you carbon dioxide and water, but it's not required for you to know, yeah. They it means that the another carbon, they will give you carbon dioxide, yeah, they will give you carbon dioxide, and of course you will get water also. No need to learn how to balance, okay, because I've seen question in the past year paper, yeah, they have given 2 carbon over here, and then students know that it's going to be oxidized to become carboxylic acid, yeah, but don't know whether how many carbon that they need to put, yeah, because students will think that maybe carbon, another carbon, then only you have this, okay, this is wrong, yeah, this is wrong. So it means that, okay, it's going to be still 1 carbon, okay, still 1 carbon. So you do not need to know how to balance that, okay, so it's just not required, okay. So here, okay, you can read over there, they say alkanes, yeah, alkanes are not usually oxidized by potassium manganate, but in alkyl arenes, okay, the alkane side chain is oxidized to become carboxylic acid, yeah. So just I want to ask you, yeah, so let's say, see whether you guys memorize this. Josh, can alkene be oxidized?
Alkene?
Yeah.
Yeah, into alcohols or carboxylic acids.
Yeah. So do remember, okay, this one last time you learned, okay, when alkene, they do get oxidized. It depends on, go and read about this, yeah. So it depends on what you have, okay, if you break the double bond. So if you have H and H, they will give you carbon dioxide and water, okay. If it is going to be 1R and 1H, yeah, so they are going to be oxidized to this, and then further oxidize, okay, to become carboxylic acid. Yeah, I hope you remember this. And then if let's say the side chain over here is going to be 2 R groups, okay, if let's say this is going to be another R group, okay, then it's easier, C double bond O, and then you have R and R over there, ketone. Okay, there will be ketone will be given. So then you join this one and this one and this one. Yeah, so this one is actually just I'm trying to recall the oxidation of alkene, okay, with you. Okay, but generally alkane, they don't get oxidized, but for alkyl arenes, yeah, they do oxidize to become carboxylic acid. Okay, so they say methyl benzene is oxidized, okay, the condition reflux, okay, with alkaline, okay, so alkaline potassium manganate, okay, and then they say with acidified dilute sulfuric acid, okay, or it can be also done under acidified potassium dichromate. Okay, so you can actually just read, yeah, so basically they can be reflux okay, with potassium manganate, but normally we say acidified potassium manganate. I think there is also alkaline. Yeah, you need alkaline condition also. Okay, so in summary, okay, if I bring this here, earlier, okay, when we did the Friedel-Crafts reaction, yeah, Friedel-Crafts reaction is basically just now benzene. So Friedel-Crafts reaction, if I want to write it bigger, okay, you can see it's a reaction involving benzene also. Okay, it's a reaction involving benzene. And then, okay, the last one that we did just now, okay, which is going to be the oxidation, okay, that is involving CH3 or any alkyl benzene. Yeah, so this one plus O, okay, if you memorize 3, it's much more easier if you memorize. Okay, so they are going to give you carboxylic acid, acid benzoic acid, yeah, they call it COOH. Okay, and then you are going to have, okay, water over there. So this is going to be the reaction, yeah, and you reflux, alkaline, okay, KMnO4, okay, acidified, okay,